Okay, so we are just waiting for the jury members that went to the restaurant. Hopefully they shouldn't be too long now. Okay, so they arrived at the campus, so it shouldn't be too long now. I think so.
Hi, can the remote examiners, can you hear us?
Perfect.
Yeah, great. Brilliant, thank you.
I don't know if you can see me. Hello, everyone. Thank you very much for joining. Can you hear me, Richard, Emma, and Sebastian?
Perfect. Yep. Yes.
Yes, yes.
Excellent. So thank you very, very much for joining. We are a bit late, just leaving the lunch, so sorry for this late. So just reminding very quickly, the candidate will present during 45 minutes the work that he did during the PhD, and then we'll have a round of questions, starting by the reviewers and then the examiners, the chairman, and the supervisors that can also ask questions if they want. And then we'll have the deliberation. And because we are part online and part on site, we'll keep this room and we'll ask everyone to leave this room during the deliberation, and then they will be back in the room afterward. Is that okay for you?
Good.
Excellent. So we have a chairman for this PhD committee, who is François Tajani, who is full professor at the University of Rennes 1. So now I will take the token to François that will lead this ceremony from the beginning to the end. So talk to you later.
Thank you.
Thank you, Benoit. Welcome, everyone. So today we are going to listen to the PhD defense of Pierre Jeanjean, who is going to tell us about his work entitled IDE as Code, Verifying Language Protocols at First-Class Citizen, and who will defend his PhD in front of the jury comprising the following members. Mr. Richard Page, who is a professor, full professor at the university, at McMaster University in Hamilton, Canada, who is present remotely. Professor Mark van der Brand, who is a full professor at the Technical University of Eindhoven in the Netherlands. Both of them were reviewers of the PhD. And Mr. Sebastian Erdweg, who is a professor at in Mainz, in Germany, who is an examiner. Mrs. Emma Sodenberg, who is associate professor at Lund University in Denmark. Professor Olivier Barré, who is a professor at the University of Rennes 1, and who is one of the two co-supervisors. Mr. Benoit Combemal, who is professor also at University of Rennes 1, who is the main supervisor, and myself, François Tajani, professor at the University of Rennes 1. So, Pierre, the floor is now yours, and you have 45 minutes to present your work.
Okay, thank you very much. So, hello everyone, and welcome to this PhD defense. It was already been said before, but my name is Pierre Jeanjean, and today I will present to you the work I've been doing as part of my thesis for a few years now with the Diverse Research Team, which is a team that focuses on software engineering and studies software in all of its forms, basically. And today, in particular, with this presentation that is called IDE as Code, Verifying Language Protocols as First-Class Citizens, I will focus on software language engineering and also development environment. So first of all, why is it interesting to study development environments? Basically, nowadays, we see that software are becoming increasingly complex in terms of their structure, but also in order to write it. And modern developers, in order to cope with this, need a few facilities. In particular, they need to have the tools in order to have a deep comprehension of the systems that they are designing and or implementing. They need an environment that can support collaboration between them and other developers, since nowadays a single developer just cannot possibly do everything on its own. And they also need advanced debugging facilities for whenever there is an issue with the program and they need to find where this issue comes from and how to fix it. So basically, if we want to support modern software development, we actually need efficient development environments that at least gives all of these things. And development environments have come a long way. If we take a look back at in the 80s, for example, they were very different than they are now. Development environments were basically just a set of several completely independent tools. For example, you could have a very basic text editor, which had limited or even in some cases absolutely no syntactic support. You could have other tools such as formatters that were completely independent from the editor, so you couldn't even have a preview of what you were going to get by running this. If you wanted to compile and run your program, you had to do it externally in another terminal or console. And even debuggers had very basic command line interfaces with absolutely no link to the source code that was being manipulated by the programmer. This environment had a lot of issues, which were quickly identified in works such as the one from P.S. Newman in 1982. Among other things, it was noted that with such environments, there was a lack for a complete documentation of the system, since everything was deployed on a lot of different tools. Tools were underused, there was limited collaboration between these tools, and it was actually very costly to maintain this set of tools. So, following P.S. Newman's advice, people went towards integrated development environments, for which here's an example. So here, it's a picture of the Eclipse IDE, which is short for Integrated Development Environment, where, as you can see, the point is to really be able to embed as many language tools as possible. So all of the tools that I presented earlier, you can see them in this picture. And you can see even more tools. It's actually a lot of tools in there. However, with such approaches, now we see other issues. First of all, by embedding as many features as there are currently in IDEs, we have come to a very, very, very large set of features, and actually maintaining all of these is also costly, which is why IDE manufacturers usually tend to target one specific language or one family of languages that might share similarities, since they just cannot target every language existing. And this leads to a fragmentation in the programming environments, where we see people using one language more than the others, going for the IDE that offers the best support for this language and disregarding all of the others, no matter the tools that they offer. And now we see another issue, which is that the number of programming language is rising considerably in recent years, which is even more true when we consider domain-specific languages that I will now introduce. So domain-specific languages, or DSLs in short, are languages that are specifically designed in order to solve a given problem in a given domain space. And they have a few specificities. First of all, they are quite numerous. They can be as many DSL as possible, as problem possible. On the left side, for example, you can see an illustration of the logo DSL that can be used in order to draw images. And since they tend to give tools in order to fix specific problems, that also means that they're required to provide specific facilities to their users. And with the logo example, basically, if you have this environment but without a graphical representation of what you're actually drawing, then there's just no point to using this language. So it's very tied to its environment. So on one side, we have a lot of different IDEs that cannot support all of the existing languages. And on the other side, we have a lot of languages which would benefit a lot from being embedded in multiple development environments, but having an implementation in a new development environment would mean implementing all of the tools for this specific environment, which is not sustainable. And this particular issue has been labeled as the IDE portability problem, and has already been addressed by a few previous works, notably this specific work, the IDE portability problem and solution in Monto by Sven Keidal in 2016. And right now we are starting to see a few industrial solutions based on the results of these previous research works. The most famous right now being the language protocols, in which basically we can have a complete separation between the development environments, which are the client on this slide, and the language services that are offered in independent language servers. And basically, by simply implementing these protocols, we can have the language servers on the right. There's one for the Java language, one for the Python language, that can be used in any client that implements the language protocol as client. So in this case, there are two IDEs, Eclipse and Microsoft VS Code. There are lots of language protocols that exist right now, and this number is growing even more at all times. The most famous is probably the language server protocol, which was the very first to be designed, and it was embedded in Microsoft VS Code as the first implementation. This protocol, LSP, provides all of the language features necessary in order to manipulate textual syntax of languages. There are also protocols such as the graphical language server protocol and the graphical server protocol that can be used to manipulate graphical syntaxes. Then we have a debug adapter protocol for debug, the build server protocol for building programs, and the test adapter protocol to run tests on these programs. However, even with this solution, we still have a major issue with domain-specific languages that still offer some features that are very specific to one language. So basically, there are no protocols that have been made for these specific features, since they're just one language that needs it. So in this case, the visualization. And this is why we are trying to go beyond the scope of language protocols, since there's a bit of an issue with them, which is the fact that when they were originally designed, they were designed with a very specific use case in mind, which was to have support for the most popular programming languages at the time, which were all general-purpose languages, and provide the support for these languages in one specific IDE, Microsoft VS Code. So as a consequence, there are a few things that they do not consider at all in language protocols. First of all, they do not consider reusability. Most implementations are completely monolithic, so it's not possible to leverage on already implemented services. They do not consider extensibility, since, like I said, the set of language features is fixed because it is based on a set of existing languages, and the the set of features available inside a specific IDE. As such, they cannot cope with DSLs. And also, they do not consider problematics about the deployment, since it was designed for VS Code, which was one client connected to one specific language server at a time. And the fact that there are no concerns about deployment could hamper the way for having distributed environments in the future. As such, this leads us to the following research question: how to deliver a customized development environment that empowers both DSL designers, but by giving them a way to provide their language to multiple users through multiple environments, and users by giving them a way to have an environment where they can have any service that they need and that they use for a given set of languages that they know about. From that, we derive a few challenges. First of all, on the topic of reusability, is it possible to establish a hierarchy between the protocols in order to leverage on reusability and composition between the language services? About extensibility, is there a way to provide a specification for domain-specific protocols in order to be able to support very specific language features? And finally, about deployment, is there a way to support complex deployments of language services, in this case through a service-oriented architecture? So now I will give you a quick overview of the state of the art and practice. Basically, this work is at the intersection between three main domains. The first one being language engineering, where we manipulate DSLs, and we are trying to work with multiple execution tools, such as REPL or debugging. I will go back to that later. There's the domain of development environments, since we target IDEs, but also other environments, such as notebooks, that we'll also come back to later. And we are trying to make use of language protocols. And there's also a side on service-oriented architecture. Basically, with this thesis and its title, we take inspiration on infrastructure as code as a basis. And we are looking on microservices in order to be able to support the deployment of all of these services. Now that I gave you a quick overview of the current state we are in regards to development environments, I will start by providing a bit more information about the main contributions of this thesis. And at the end, I will give you a conclusion and the perspectives that we are looking at for the future. So the first contribution that I will talk about is the one that gives its name to this presentation, IDE as code. So basically, the idea of IDE as code is to provide to language users an environment, a development environment, completely distributed, which has a few benefits. First of all, this means that we can provide a completely persistent instance of the IDE. With the recent COVID pandemic, we have seen that it's not always possible to provide developers with a stable working environment. So having a persistent instance that can be accessed from anywhere at any time for developers is a very important challenge for the future. And also, we want to be able to leverage on very heterogeneous resources, since the practice of programming is constantly evolving, and now there are, for example, the need to, in some cases, run a lot of executions and get a lot of data from these executions, which is not adapted to doing work on your laptop, for example. So we might want to benefit from having access to servers or databases in the cloud in order to do this kind of things. It's programming is just not limited to writing programs anymore. And in order to customize this environment, we want to provide a way for the language users to refine the configuration of this environment. So we want to give them a way to tell and to write explicitly what they want inside this environment, what languages they want, what tools they want for these languages. And we want them to be able to manage the deployment of all of these services, depending on the infrastructure that they have access to. And in order to have a first configuration for this environment, we want to give language designers that have a possibly good knowledge of the language they are designing and how to use them. We want to give them a way to specify some presets for configuration and deployment based on their knowledge. That is what the users will refine later. Also, language designer usually provide the specification of their language from which they can define all of the tools that will be used by the language user later. And here we want to give them the possibility to also specify the protocols that these different tools will use. So here we had the language service protocol as a thing that language designers can provide. And from these specifications, we can then derive language service packages that are the language services completely independent that will then be referenced by the configuration and that will be deployed inside the environment. So here we'll show you a quick example of what a definition for a specific protocol could look like. So here I take as an example the view for logo that I showed earlier. How can we define the protocols in order to have the execution interacting with a view for this turtle? So first of all, in protocol definition, we need to be able to specify data structures. In this case, we have points, we have segments, and we have a turtle which just has all of the position of the turtle at a certain time. Then we need to define the events that can be sent between these services. So here, in case that the turtle is moving, we have an event to notify that. We have an event if there is a new segment to show. And we also have an event clear in a case where we need to clear the board because someone used the clear command. And then we have the definition of the packages that make use of these events. So here first, I have the first service, which is basically a backend service called logo execution that depends on having an actual execution of a logo program. And from that, we have a sequence of operation properly defined where whenever this service receives a step, it can call its method isClear to check if there is a need to clear the view. If there is, then it can send the event, and if there is not, then it just does nothing and go to the next one. Then it updates the position of the turtle, and then finally checks if there's a need for a new segment and sends it if there is. And then we have the UI service called Turtle View, which depends on having this service running somewhere in the environment. And whenever this specific service receives an event, it will just call the corresponding method. So to sum up this contribution, with IDE as code, we propose an architecture that can support complex deployments of language services that leverage on heterogeneous resources and can also let users have access to a persistent environment. We provide a DSL that can be used to define domain-specific protocols that will then be used as a communication mechanism inside this environment. And finally, we can define language service packages that can make use of other language service packages that might use completely different protocols, but that's also something that can be defined through the specification. This particular contribution led to publication in an international conference in 2021. So next, we basically, now that we had this idea of that we have this IDE for a development environment, we need to think about the hierarchy between all of these services. So one possibility for us was to look into repo interpreters as the most basic execution tool that might be used to drive other execution tools. So here in particular, I will introduce repo interpreters, and I will talk about designing repo interpreters for domain-specific languages. So first of all, what is a repo interpreter? REPL stands for read eval print loop, and basically a repo interpreter is just an execution tool that provides users a way to interact directly with a programming language. There are REPL interpreters available for most of the general purpose languages. Yeah, for a few examples, we'll cite Python, which is probably the most common. When you run the Python interpreter without any parameter, what you get is a shell in which you can define classes. You can basically you can execute any statement of the language and evaluate any expression of the language interactively. And another repo interpreters that is for Java this time is called JShell, and is provided in the official Java distribution. And in this particular case, it's a bit interesting because we see that the syntax can be a bit different from a regular Java program, in the sense that at the top level we can write statements, we can define methods, we can use methods without having the need for a definition of a class and a definition of a main method, for example. This kind of interpreters have several benefits. First of all, they are very interesting for learning, since people can just use them without interact directly with some language element without the need to respect perfectly the structure of the language. So for an experimental approach, it's for an experimental approach of learning, it's very interesting. They're also good for experimenting, since they provide a way to interactively use some new structure. For example, you can incrementally try to interact with an API that you have never tried before, or to use a protocol. And another one of their benefits is that they provide an integration with notebooks, which are environments that I will talk a bit more later. And this integration is basically for free at this point. So in order to provide repo interpreters for domain-specific languages, we first had to have a better understanding of what were the main differences between these interpreters and regular language interpreters. So here I have a quick figure showing what would happen with a regular logo interpreter, where basically I have a complete logo program on the left, I send it to the interpreter and I get an output, pretty straightforward. And the main difference with a Reaper interpreter is the fact that I no longer have one program. I have multiple code snippets of different kinds. And for each of these snippets, I might have different outputs depending on the snippets I used and the output that's the most interesting for the user, depending on the snippet. And for each of these executions, there's one context that needs to be kept and reused for all the snippets, basically. So these are the specificities of Reaper interpreters. The fact that there can be multiple executions with one context, and also that there are multiple entry points. Entry points is a term that we use to define the language, the syntactic elements that can be parsed and interpreted by interpreter. So here I will show you the approach that we derived in order to get Reaper interpreters for domain-specific languages. First of all, we start from having specification for this DSL. A DSL specification basically has three parts. The first one is the abstract syntax that defines all of the concepts that the users can manipulate from the language. We have the concrete syntax that gives an actual representation to this concept, and it's basically what the user sees and actually manipulate. And then we have the semantics that provides the behavior of all of these concepts and by extension gives meaning to a program written in this language. From this specification, we provide a description of a Reaper that we add to the set of specification. So here, in order to detail this specific description, I have here an import command that basically tells us what is the abstract syntax that we want to use. So in this case, we take the abstract syntax of logo. Then we define the context that will be persistent between the execution and be reused for every instruction. So here the context just stores a turtle and a symbol table, which are concepts defined in the base language. And then we have an initialization method that will be called when instantiating the interpreter, and will set all of the default values for these attributes. And then we have the actual instructions, where basically we provide a mapping between the concepts of the abstract syntax. So in this case, in the first instruction, we have a mapping between the forward concept of the logo language and an operation from the semantics. So here we have the execute operation. And we also provide in this mapping the output expected for if a user actually uses this specific instruction. So in the case of forward, we basically just provide the new position of the turtle to the user. And in the case of pen down, which is the last instruction here, we just notify the user that the drawing mode is now enabled and that any movement will draw something on the screen. From this extended set of specification, we generate a new language, a new DSL. I will here show you what is the process. So on the top, you have the abstract syntax of the base language, the first one, where it's very simplified, but it should be enough. So here you have only one entry point in the base language, which is a logo program that can have multiple statements. And one of the statements, the forward statement, can also have an expression. And from these concepts, we derived another abstract syntax, an extended abstract syntax, where we define in the interpreter class on the right the context that I showed earlier. So every attribute and initialization method. Also, this specific interpreter will have a method to execute an instruction. And for the two statements that I want to transform into instructions, I basically add wrappers. So there's a wrapper for the forward concept, which is called forward instruction, a wrapper for the pen down concept called pen down instruction. And these wrappers will become the new entry points of the language. Also here I'm showing this transformation for the abstract syntax, but it works basically the same for the concrete syntax. I also have wrappers for the concept of the concrete syntax and also for the semantics. And now that I have this new DSL properly defined, I can actually use it inside an interpreter with the reports or readable print loop mechanism. So here to showcase this, I am in a situation where I have an interpreter, so a context instantiated, and I had previous instructions executed at some point. And now I get a new input. This input will be parsed, it will be read and parsed into an instruction by using the specification of the DSL that I generated. Then I will set a reference to the previous instruction in order to have a proper history between all of the instructions that I will execute. Thanks to this history, I can resolve any reference if there is any, and possibly run validators if there were in the first language. Then I send this instruction to be interpreted to the interpreter. This gets me an output, and I can just loop for that until one of the commands received is quit, for example. And having this Reaper interpreter, like I mentioned a bit earlier, gives me a way to have an integration in environments known as notebooks. So basically here you have a screenshot of a notebook called Jupyter. And this kind of environment merges two programming practices. The first being literate programming, which gives users a way to incrementally write their programs by detailing all of the steps and the thinking they have done. So basically by documenting everything. And exploratory programming, where users can have several pieces of code and execute them in any order that they want at any time that they want, basically in order to solve a problem by trial and error. And from these notebooks have been used a lot in different domains in the past years, and by just defining a Reaper interpreter for a DSL, it's possible to use this DSL inside these environments. So to sum up this contribution, if we have DSL specification, we can actually extend them by providing a description for Reaper interpreter. And then from that, we have enough to actually generate a Reaper interpreter that can be used. And these specific interpreters can be embedded in development environments or even drive over language services, such as notebooks, for example. This specific work led us to two publications during this thesis. So, sorry. And now, finally, I will mention my last contribution during this thesis. So Reaper interpreters were a way for us to try to find the most common execution tool, the most basic execution tool that there could be in order to define the hierarchy between the execution services. This didn't work, so we went a bit deeper, and in the end we have this contribution, generic interface for language runtimes. So basically, if I resume a bit what I was saying earlier, the current practice in order to have language services is to start from language specification and generate language services. So for example, an interpreter of programs. Now we can also generate a wrapper interpreter. And in some cases, we might also need a debugger, for example, in order to have a better understanding of what's actually happening and provide this and provide to the users a way to understand this. But in this specific case, this means that in order to execute a program, we already have 3 completely different tools for which the actual execution might not be consistent between them, since they are completely different. So the idea here would be to instead of having all of these different tools specific to one language specification, to generate only one component, a base runtime component that would expose a specific interface, here a runtime interface. And from this interface to have all of the other execution tools be completely generic and consume this interface. So in order to do that, we basically took a look at all of these 3 different execution tools and listed their requirements. So in the case of a program interpreter, we need to have a way to initialize the context, since when we execute a program, we might probably have input parameters that we need to store somewhere in the context of this program. Then we need to be able to execute the complete program, and we need to notify the user that the execution terminated. For a wrapper interpreter, we do not need a specific initialization because we just started without any parameters, and then we can actually just add, call it interactively in order to set the context if we need. But we need to be able to interpret code snippets, and we need to be notified of all of the changes inside the context of the interpreter, since it's interactive. So the user needs to be able to have a proper view of the current state of the context. And there's no need for termination too, because the user is the only master of when this interpreter terminates. And for a debugger, we need to be able to notify of every start and stop of execution steps, which are basically the states of the program that can be observed by someone using the debugger. And we need ways to be able to read and modify the values from the context of the execution. So from all of these requirements, we derive the following interface, where I have both requests and events, where events do not require an answer from the other side, basically. I have a request to interpret some code, which might be either a complete program or a code snippet, depending on the available entry points. This gives me a reference to the next step to execute. Then I have the step request that will execute the next step and provide me with a reference to the even next one if there is a need to actually run it. I have an event whenever a step ends with a reference to this specific step. I have an event when there are no more steps to execute, which is called finished. And then in order to manage the context, I have 2 requests, read and write, in order to read and write values from this context. And I have an event modified whenever there's a change in this context that is due to the execution and not the use of the write requests. And through this interface and implementations of language services on top of it, we could get this specific environment. So here I have on the left side Jupyter Notebook. So like I showed earlier, by having a repo interpreter, I have a Jupyter Notebook for free. In this case, it's no longer Logo, it's Mini Java, but it's basically the same thing. On the right side, I have a UI in order to debug the code I'm currently executing. And here, one thing in particular that's interesting is the fact that this cell is the one being currently in debugging process. So here you can see that the execution is stopped on the third line, which shows also on the stack on the right side. And during the debugging process of this cell, I can still interact with the interpreter, and I can still execute other cells. So for example, I can just use the get attribute method and B in order to get a specific value from the context. So to sum up this contribution, we can have a common interface in order to which multiple runtime language services can adhere to, which provides consistency between the multiple services. And we can, from that, obtain an environment that provides all of these services, but with a deep integration between them, meaning that we can use all of them at the same time for a single execution. Now, to finish this talk, I will go for the conclusion and then detail the perspectives of future works. So first of all, to sum up the contribution I showed here, I talked about IDE as code, in which we reified language protocols and opened the path to support service-oriented development environments in the future. I talked about repo interpreters for DSL with a generative approach that lets us obtain interactive development tools that can then be used to drive other tools, such as notebooks. And finally, with a generic interface for language runtime, we established a hierarchy between language services that can now leverage on having a unified semantics and be deeply integrated with between one another. For the perspectives, first of all, in the short term, it would be quite interesting to pursue the taxonomy of language services, since right now we have worked mostly with runtime services, but there are a lot of other different services, in particular UI services. With these specific services, there can be a lot of different environments that require them. I can see, for example, IDEs, but also notebooks, web pages, and even terminal UI, such as NeoVim or Emacs. And I honestly, right now, have no idea how I could define these services in a way that could be implemented in all of these platforms at the same time. So that's still something open. And for long-term perspectives, we need to properly study the impact on performances when we have a fully distributed development environment. So we don't have this fully distributed development environment yet, so it's not possible yet, but whenever it's possible, it will be very important to do that. This follows the work of Coulon et al. Coulon was another PhD student in this team that focused specifically on the services offered by LSP and their impact on performances when they're distributed. So this would be a follow-up to this work, but for the whole environment, basically. And then, in order to improve the user experience, considering that we will get a performance impact, we need to look for multiple redeployment mechanisms. First of all, can we provide dynamic redeployment of the different services to leverage on, for example, proximity or available resources? Then about the transport of the data itself. Right now, we are generating language execution tools or language services from the specification of the protocols, which fixes the way that data exchanges inside the implementation. But if we could find a way to directly interpret this language protocol specification, we might have a way to modify on the fly the way data is transported. And also, we could even go for completely dynamic redeployment of the architecture by, for example, getting back multiple language services, putting them back together, and even running them directly inside the browser of the user through WebAssembly, for example, that could let us cope with network losses that will obviously happen in this scenario. And finally, our longest term goal is to have an actual impact on the way that language protocols are designed and the way that modern IDEs use them in order to make them consider the need for all of the concerns that we mentioned earlier. So extensibility, modularity, and deployment of the different language services. So thank you for your time and attention. And now, if you have any question, you are free to ask them, I believe.
Thank you very much for your presentation. So we'll now move on to the questions. And as is usually the tradition, we'll start by your two reviewers. And as it's also tradition, we'll start by with the reviewer who is the furthest away. And that would be so Professor Mark Page. So Mark, the floor is yours. Oh, sorry.
Richard Page.
Sorry, Richard. I'm sorry. So Richard,
That's quite all right. I knew what you meant, and indeed I am the furthest away. So Pierre, thank you very much for the opportunity to read your thesis and to review it. I found it very interesting, and I learned a great deal by reading it. I have some quite general questions to start with, and some of it is to try to distill some of your experience in working with this new way of developing IDEs. So
Okay.
one of the last things you commented on in your presentation was about deployment of services. And I was wondering if you had a view on how that should be done in the future. Based on your experience in your thesis, is service deployment something that should be configurable and specifiable by the language engineer, or is this something that should be hidden behind the scenes and done as automatically as possible? Do you have a view on that?
Well, I believe that it needs to leverage on the knowledge of the language designer at the very least, since, for example, language designers are the ones who know the best the way that the services are actually implemented. So they know what are the actual requirements for resources of these different services and if they would benefit from being closer or not to the user. So at the very least, that is some information that needs to be specified by the language designers and that we need to leverage on. But once we have this information, then the actual redeployment can be done behind the scene, depending on just the way that the network is currently in, if it makes sense. So,
and I guess that assumes though that the language engineer has enough information to basically configure the services in advance. But I mean, as you know, with say microservices architectures of any sort, things change and load changes, and the language engineer might not be able to anticipate everything. So do you think there's any role for the language engineer to get involved with, say, redeployment or reorchestration at some point? Or is this something that should be totally hands-off?
So, are you talking about giving some information to the language designers about the way that the environment evolved and
Perhaps. So it may evolve in a bad way, and performance may drop, for example, or a service may become unavailable or temporarily unavailable. So you might give feedback to the language engineer and almost throw up your hand and say, "Help! What do you suggest that we do in this situation?" But I don't know if that's what you think is appropriate, or if it should be entirely automatic.
No, it's definitely appropriate to do something like that. But so about your first question, well, my take is that we need to leverage as much information as we can from the language developers, but they obviously won't be able to do everything. So at some point, yeah, we will need to just make decisions based on what we have and not what they can provide.
Sure, no, that's okay. I just wanted to get your general view on this. My next question is coming back to some of the early motivation you gave, which was to.
Sorry, I couldn't hear.
Sorry. My next question is related to some of the early motivation you gave for treating IDEs as code. You talked about better integration of language services, which is of course an excellent thing to try to do. But I'm wondering now about, let's say you build an IDE using language protocols and treat services as first-class citizens. Are there any consequences to then integrating that IDE with traditional software engineering tools that have not been constructed in this way? So I'm thinking of build tools, continuous integration tools, your standard static analysis tools that haven't been constructed in this model. Like, is that possible? Or is it hard? Is it easy? What do you think?
So basically, what you're asking is if we have language services derived from the language specification, like right now, but without any protocol specified, can we still integrate them? Is that what you're asking?
That's one aspect of the question, and I'd like to hear your view on that, certainly.
Okay. Well, I do believe that even if a language service wasn't designed directly for this specific use case in mind, there are probably a lot of different cases where it would make sense to just define a protocol using this implementation and integrating this implementation in the environment. I don't know. Well, I wouldn't say that it will always be possible, but another thing that I want to clear is that one of the main goals is obviously to provide to the environments that are used to generate these services the support for having the specification of the protocol and by extension the compatibility with this distributed environment. So I believe that in the end, if we actually were to reach the vision of IDE as code, we would have all of these tools directly inside the language workbenches. So there wouldn't be any tool that doesn't define explicitly its interface.
Okay. Okay, that's fine for now. Maybe we might come back to that a bit later.
Okay.
I've got I'll ask a couple more questions and then I will pass the baton. So one of your initial motivations was LSP and you know, building on, improving on that. Did you run into any real difficulties in basing your ideas on something like LSP? Like, was there anything that was really difficult to get past and made you think, oh, we should actually just redesign this from scratch?
Well, that's basically how we arrived to a situation where we needed to extend these protocols. So I haven't studied LSP at first. I started with the debug adapter protocol. And one of the first issues I suffered was the fact that in the debug adapter protocol, every operation for going forward during the debugging process is very well explicit and documented. But if you want to manage omniscient debugging, then you don't have any support to do that. You just have one request, but that's definitely not enough to provide the whole scope of omniscient debugging. So that's basically the first time where I said, and well, we need to have a way to extend this protocol. We need to have a way to specify only the omniscient debugging part of the protocol, and to be able to couple the two protocols. So basically, that's, yeah.
Okay.
As soon as I tried to use these protocols, I stumbled on this issue.
Sure.
That's what
makes
motivated
sense.
us after that.
And the sort of corollary to that question is, was there anything that just worked beautifully, that you ran into some sort of architecture or design problem and there was a feature of LSP that you just said, oh, okay, that's exactly what I need?
Well, for LSP, the completion, what I mean by that is that for most of the implementations that I've done, I do have a LSP server that's generated from the language specification, and I don't touch it. I just use the services that it offers, and they work pretty well because I don't use them extensively. I just need a way to have a compression, for example, in the REPL interpreters. So I get that for free. So definitely there's definitely a lot of advantages of having these protocols.
Okay, great. So my last question, possibly for now, is what is the knock-on? What is the effect on traceability? So suppose I want to do end-to-end traceability, say from a requirements model through to Java or Python code, and I want to make use of this effectively services architecture that you've proposed. Does it make supporting traceability more difficult or easier? What's your perspective on that?
What kind of traceability are we talking about? Just so we are.
So I want to support traceability from requirements through design to code in order to support change impact analysis or requirements coverage or something like that.
So that's something I haven't thought about.
That's also okay.
Yeah, I cannot answer to you right now, but whenever the defense is done, if I have any input on that, I will be happy to share them. But right now, I don't know.
That's absolutely fine. So, thank you very much. I will pass the token to the next person, Mark, I suppose.
Yes, indeed. Thank you, Richard. So the floor is now to Mark, over to you, Mo.
Okay, thank you. Also, let me thank you for your thesis. I also enjoyed reading it, and I also enjoyed listening to your presentation, because your presentation, in my opinion, also adds some extra information to your thesis and clarifies at least a number of things. And I also am grateful for Richard to already have asked some questions that I would like to ask as well. So thank you, Richard, for that. I would like to tackle actually a different angle, because in the beginning of your presentation you made the remark that you have designers, language designers, and you have actually the users. And if I look at what you have done, my concern is a little bit that you focus very much on the language designer and implementation part, and you focus less on actually how the users experience this. So I would like to ask a few questions there, because one thing that you said is, okay, there should be option or possibilities for collaboration. In the next sentence, you more or less say, yeah, a user should be able to configure his IDE in a personalized way. At least that's how I interpret it. Isn't that conflicting?
I don't think so. I mean, the actual development environment is, well, even right now, if we have multiple IDs, people can already somehow configure them to remove a few features and install plugins, and it doesn't hamper collaboration at all. So I would say that honestly, the actual development environment should be personal, and that it wouldn't cause an issue for collaboration. And at the same time, isn't a personalized development environment just another view of the whole system? Right.
Yeah, maybe a bit more background information on this. So you have provided these services. Suppose that I, as a user, configure my environment in such a way that a certain service is available, and I develop my program I develop my model using this service. So then I put it into a version management system, and my fellow developer or user is continuing with that. But he has a different environment in which that service may not be available.
Okay, so so there are two things here. First of all, is the service unavailable right now in the environment but can be installed? So in this case, it's not hard, at least for me, to imagine that the IDE could have a service just checking the requirements for a project and then installing everything that's actually required. So that can just be another layer on top of the current configuration. Now, if the user is inside an environment for which there's absolutely no way to install the service, then I have to admit that I don't know how to manage that. Yeah, that.
Or is it the case that you would like to prevent this actually? That you say if I install a service, then this service is automatically made available to all the people that that work in the same environment or in the same ecosystem.
So basically, it could be tied to the repository inside the version control environment. That's actually interesting. I haven't thought about providing the actual environment with all the tools required for a specific project. I mean, I considered having a way to define the dependencies inside the repository for what are the necessary services, but not about how to actually provide these services when there's no possible way to have them. Like, for example, if there's on a server that you don't have access to. So I haven't thought about that, but that's a very good point. I guess that, yeah, a way could be to just have a runnable version of the services directly stored with the rest of the project on the repository. But that's I would have to think of a better way. I think it's
Okay, so along the road of the user, did you do any validation with users? So you show a number of languages, you show a number of environments that have been constructed, but did you give, let's say, to a number of students, master students or whatever, your system and say, okay, let's try to develop an environment or try to develop a language given the microservices that you made and the protocols that you made available?
So I have not, and the main reason for that is the fact that right now I just don't have enough language services to have an interesting to have such an exercise, basically. I do have a few services that I used for my experimentations, but basically, if I asked someone to just configure its environment based on the sets I have, it will just take everything and be done with that. So I think that in order to do that, we would need to wait a bit and have a few more services before it's actually even possible to consider that. Yeah.
And what kind of services are you thinking of that should be added? Is that along the line of beautifiers, formatters, or is this more on the semantical level?
It's more on the how to say that, alternatives. Because right now I don't have alternatives for all of these services, basically. If you want the beautifiers, it will be the beautifiers from that you got from your language specification that might be generated through xtext, for example, but I don't have any other. So if you want a beautifier, you will only have one at your disposal. So I would say that as long as I don't have any alternatives for all of the different language services, then I just cannot ask someone to, try to configure his environment with the alternatives that he likes best.
Okay, and so the examples that you have in your PhD thesis and also that you give in your presentation are very textual oriented. Eh?
Yeah, true.
You are probably also familiar with the work of Maurizio Verano, who looked, for instance, into block-based languages.
Yes.
Would you be able to do something similar? So is the concrete syntax really married to the parsing step, or could you say, okay, I can also use a different visualization, graphical, block-based, or whatever?
Well, right now I don't see any reason why I couldn't have an integration of such a service inside the environment. Because if you have a concrete syntax, that means that you also have the abstract syntax that goes with it, and the abstract syntax should be the same or shared between all of the different representations. So you have a representation. How to say that? You have a main representation that you can just use for all of the communication. So if I just have a service that provides a graphical representation of my model, and I can just send this model through its abstract syntax, then I don't have. Well, I don't see any thing that could hamper the integration of such a service, basically. But maybe I misunderstood your question.
Yeah, the reason for my question is that if again from the end user perspective, textual languages are sometimes not an optimal solution.
Yes.
And if you look at people from other disciplines, for instance, mechanical engineering or electrical engineering, they sometimes use very graphically based languages.
Yes.
And I was actually earlier this week, I had a discussion with somebody from industry who said that they were looking very much into indeed developing domain-specific language based on block-based environments, because engineers, mechanical engineers, understand this immediately, whereas if they look at text, they get hopelessly lost.
Okay.
So that's why my question is, okay, to what extent is your environment really text-based, or would it be reasonable simple to say, okay, I throw out X-tags, I throw out the parser, and I integrate, and I allow the user to select icons and place these icons on a canvas, and in that way create a program?
So basically, I would answer that the environment is neither text-based nor graph-based. It's model-based, and the textual syntax and the graphical syntax are just views of the same model. So as long as I can exchange the model between all of the services, then I can do both.
Okay, so a completely different question, if I may, a completely different question from my perspective is on the use of these REPLs and interpreters, etc.
Okay.
Is it possible to create an environment in which you have different DSL next to each other?
Okay.
And also for each DSL, a separate interpreter or a separate REPL. So can they live next to each other and communicate amongst each other? So you have a language in which you have a DSL that is, for instance, focusing on state machines, but in the state machines there is, for instance, a piece of Java code that needs to be executed because a state has to be updated. And you have, so in the DSL for your state machines and the DSL for this Java-like sublanguage.
So that's one of the goals, definitely. I haven't experimented with that yet, But that's definitely one of the things that I would like to extend a bit more, and it should probably have been in the perspectives actually, but I completely forgot about that. But yeah, that's something I plan to experiment with at some point, but right now I cannot ensure that it will work, basically.
And can you think of what kind of requirements this would impose on your REPL? Just do some brainstorming there. I imagine that, as you said, that you did not experiment with it, but maybe you say, okay, but if I would like to do this, then...
If I use the approach they showed to create REPL interpreters, that just means that I would need to import multiple abstract semantics and define entry points for all of those, and then have a mapping smart enough to be able to convert a context of a DSL into the context of another DSL. So I do believe that with the same approach and just a particularly complex specification, it would just work right out of the box. Yeah, so basically what we need is the entry points from multiple DSLs, and we need to have a way to translate the values from one DSL to another and be explicit about that. And I think that's the only hard requirements, the way I see it. So, yeah.
Okay, good. I think I leave it here, so maybe the next one can take over.
Thank you, Mark. So we now move to the examiners. So I think Sweden is further away than Germany from France. So Emma, you have the floor to ask questions.
Yes, I'd also like to say thank you for the thesis. It was very interesting to read, and I also enjoyed the presentation. I agree that there were some more details that clarified some things for me. So a couple of my questions have been touched upon, so I'll see maybe how I navigate this. But to begin with, one thing that I'm still kind of wondering about a little bit is part of the argument here is this, you have these IDEs, they're quite sort of integrated, you have different services sort of on top of each other, as syntax highlighting together with completion, they kind of operate in the same space. Now you've been speaking mostly about sort of runtime services. But how does this work? I mean, when you showed your example with the Jupyter Notebook, you kind of had different views for the different services in a way. So how is this specified? How are things like this became red? Why did it become red? Where does this sort of specification?
Do you remember the number of the slide? I would like to go back to it.
Let me see if I can.
I will find it if you don't.
It's towards the end. I think you were showing logo integrated into the notebook.
The one, right?
Oh yes, this one. Or maybe a little bit around. You had a different window as well.
So in this specific example, what we have is like I said, a REPL for logo. So from that, I have what is called the kernel in Jupyter, which is basically just a small artifact that can receive requests from the front end to interpret things and show the output of things, and also to manage the completion. So I have a kernel, and this kernel directly interacts with the REPL I generated. The kernel is completely generic and just interacts with the kernel through configuration. So basically here, so I'm not showing the completion, but if I were to write a pen tab, for example, I would have a down and up as possible solutions. This specific thing just sends a request to the kernel that gets it from the REPL interpreters. When I execute something, it's the same. The UI sends the code to the kernel that then sends it to the interpreter. And then the interpreter sends back the results. And in the case of the tree on the bottom, what's happening is the fact that the REPL interpreters that I designed is specifically made to return SVG. So in this case, it just returns the diagram to render, and notebooks can actually manage SVG format, so they can just display it like that.
Okay, if you go a couple of slides down to 30, just to show you another thing. I was in the same. Oh, let's see. I have your slides here, and I think it's 30. You show something on the side. Yeah. So the current stack and kind of some kind of visualization. Yeah. So this is connecting to your specification of this particular service, right? But and then it's visualized in a certain way. You can imagine probably other ways of showing this. So how is this defined? The other one showed a picture, which is okay.
So in this case, we actually have an execution service that implements the interface that I mentioned earlier. And from that, we have the kernel, which is still there and connected to the REPL interpreter. And on the right side, we have a UI that communicates with another service through the debug adapter protocol, and also for the few commands that go on the left. Here they are not enabled, but there's also a small protocol to manage the omniscient part of the debugging, basically, but not in this scenario. So I have my debugging UI that communicates with service through the debug adapter protocol. And this service is just using the notification from the interface. So the fact that there's a step being executed, for example, to manage the execution. So I haven't detailed the transformation that I do on the operational semantics in order to get this interface exposed. It's a bit complex, honestly, but it should be part of the thesis if you want to check this specific part. So how to implement the interface, basically.
No, it's fine. I mean, what I'm wondering about is kind of where it goes, if you see what I mean. Okay. So you have this language where you specify kind of the operation of things, right? But then you can display it in different ways. And so I guess what I'm kind of building up to is that you have imagined many of these, and then also thinking about other kinds of services like code browsing or completion and syntax highlighting and so on. Like, do you think there is a risk that these end up being separate little boxes? And then their actual sort of visualization and so on, that you end up, this fragmentation that you mentioned in the beginning and the historical development, would you end up actually going in that direction by doing this? Is there a risk of that?
So I think that we still need to have a complete development environments that provide all of these tools. So not integrated on the backend, but at least on the front end to the user, to provide them a user experience where they actually still feel that they are in an IDE. But having all of these tools separated on the backend side means that we can have other interfaces too. So in this case, I'm just showcasing a Jupyter notebook with a debugger, and it's true that I cannot have the two interfaces overlapping and be properly integrated yet. But basically, my point in here is that it shouldn't put constraints on the integration of different services. IDE as code shouldn't put constraints on that. It should just let people build more minimalist environments depending on what they're doing. But all of the services and all of the integration should still be here. Just how to say that? How deep the integration goes should depend on the environment that we want. But it shouldn't. The maximum integration shouldn't be hampered from that. So I hope I answered at least a bit to your question with this monologue.
Thank you so much. It's okay. I mean, my suspicion is that there are when you because I care a lot about the user experience, kind of where this would meet the users, and kind of thinking about challenges in that space. I'm seeing a lot of textual specifications of the services, and then so that's why I think there may be some additional interesting sort of things to think about in that layer. And how to what that experience will be. I mean, minimalistic suggests that you would have few, to me, as I'm hearing it. So then, of course, the problem of combining them becomes a little bit smaller.
At a later stage, yeah.
Okay. I disconnected a little bit about my next question, which was connected also to the user experience, because that is part of your motivation, right?
Okay.
And in the end, when you were pointing to future work, you were saying a couple of different things on the last few slides you had there. And if I summarize it a little bit roughly, I'd say that a lot of them had to do with performance or something in deployment, right? So I think you had, roughly, right? But do you think there are other things that you could list in future work that sort of involve people a bit more? I mean, people could be, of course, they're affected by performance, but are there other challenges that you see in working with this system as you kind of explained in your vision?
So do you consider network losses with the performance, or?
I'm being a bit rough in my summary, but yes.
Okay. So from the top of my head, I don't have anything right now.
So I can one direction that I'm curious about. I'll give you that hint. So you say you have this. You imagine this sort of buffet of services. Right. And then you would work. So when you compose them into something, you're working with some kind of notation, some kind of configuration language. It sounds like, right? So what's the typical user, and kind of how do you see any challenges in how they would go about doing that task?
Well, first of all, we need to have the I see. So how to say that? So if we take a look at an IDE right now, for example, either Eclipse or VS Code, we see that tools are usually provided inside categories, I would say, by being close to tools that make sense when you put them all together. So that's also one of the things that I consider when I mentioned the taxonomy of language services for UI services. We need to be able to know where to put each service inside the interface if we want the users to actually find them and access them. Well, the users should know about them, since they are the ones that decided that they should be inside the environment, but still we need to answer to the change of how to place all of these services and offer them to the user. And I believe that this will come naturally if we manage to actually have this taxonomy of different language services.
How would you find out what's natural? I mean, what kind of works? How would you go about exploring that whether this is good experience for people?
And that's where we would need to have actual user studies. There are actually a bit of literature on the subject of comparisons between different IDEs and what configuration feels the most natural to some users. So we should definitely start from this literature. But then at some point, we would need to run actual studies to be sure of that. So.
Okay. We can take one. We can stop there for this one. I have one more, then I'll pass on to Sebastian. So okay. I was just curious because I like this. The vision is interesting to think about, even though I mean there are future interesting things to sort of explore here around kind of the users and how they receive it and so on. But one thing that I was a little bit curious about to hear about from you is that you're talking a lot about the IDE and focusing on runtime services and so on, and you could of course expand it to think about other services. But I mean, some of this, and this came up in, I think it was Richard and Mark they were touching upon this a little bit in their questions. What do you think about other tools in the developer workflow? For instance, I think continuous integration was mentioned. I've been spending a lot of time with code review, for instance. And some of the things that happen in code review connects to things that happen in the IDE. You can even get suggestions and you kind of can edit through the code review system in some settings and so on. And I mean, you know, sometimes people move back and forth because they're not too happy in the code review environment. They want to go to the IDE and where they feel like home, so on. And I mean, do you see a potential here? And you have this vision and this, you know, I'm generally a positive person. Don't we see, is this an opportunity here to blur the line between code review tools and IDEs?
Well, for the particular use case of code review, having all of the language services available as web services and microservices would mean that it would be possible to provide a customized environment directly on the web for code reviews. So that's one of the perspectives that I see. Just going to a forge like GitHub or something, going into a pull request and clicking on a button, and then you get the environment where you can actually try the code. And this one could be standardized between the different actors. So that's a possibility. I don't have any other one right now, specifically for code review.
I think that would be a big step forward. I mean, definitely people have questions about that in code review, like what happens when this runs. So that would be interesting, I think. I'll stop here to pass it on to Sebastian, but thank you very much.
Thank you.
Hello. Hey, can I go? I'm not sure.
Yes, please go ahead. Sorry.
Hey, Pierre, thanks very much for the presentation. I really like how this relates to the IDE portability problem that we described in Monto. And I'm going to ask a couple of questions in relation to that, because I figured that's where I know some things. So one of the key challenges we found in Monto was actually standardization. We found it was really difficult to come up with protocols for language services that would work for virtually all languages. Even something as simple as syntax highlighting, right? Then you have languages where you really want semantic highlighting. Then you have languages where you really want semantic highlighting that considers information from other files, and that you can even something as simple as that you can make arbitrarily complex. And so it seems like the having customizable services is a nice way out of this problem. But then the question I had is, doesn't this kind of offload a lot of the work to the editor implementers? Because now you have these customizable services. Who's going to implement the front end for those? And how do you manage the amount of work that has to go into that?
So the way I see it, having all of this customization available opens the way for a few things. First of all, if there is actually an interest to have a standardization for something that is shared between like 99% of the languages maybe, then that's something that we can do and that we should do. We should leverage on that whenever it's possible. And at the same time, I really consider the fact that, how to say that, some services that are very specific will obviously require specific implementations, but they should be as minimal as they need to be, which means that in the case of an execution service, for example, if I actually have a standardization for an execution service and everyone is using that, then I should also define my protocol to make use of the existing standardization. And so in doing that, I believe that the actual UI aspect will become as small as possible. So it will still be a pain for the maintainers to manage it, but it should be the smallest pain possible. So that's one thing. And the other thing is kind of what is being mentioned in this slide. So right now, UI services are very particular in the way that that's what the user needs to see. And so that's where there are the most integration with the actual environment. But if we could have a proper standardization of the way to define this this UI, we could just have something completely generic inside the environment. So I hope I made sense on that.
So then all IDEs would look the same?
There could be, but again, since they only target the smallest set of services, it shouldn't be that much of an issue. But that's actually an interesting point. Maybe we can think about a way to specify all of these elements, but that could be customized by the actual environment. Because an easy way would be to just say, let's put HTML everywhere, and that's how you render your editor. But yeah, basically we need to have a way to define enough information in order to provide the visualization while still being able to customize it inside the environment. So that would be the end goal. If we don't succeed in doing that, then yeah, we end up with the other case when it's a pain, but the smallest pain possible.
I mean, at the very extreme, you don't have an IDE at all, right? I mean, everything's on the server, and basically you get like a live scene displayed,
yeah,
which is just an image that is changing over time, and you can interact with it in certain ways. It's like like a game.
That would be the biggest extreme, yeah, probably.
I'm not sure if that's the goal. I mean, there's I guess one interesting follow-up question, which we probably can't answer today, is seems that developers have a strong tendency for one editor or the other. Like they actually have favorites, and there's probably a reason for that, or maybe not, but I don't know. Now, if we make everything the same, does that mean half of the developers will hate what we make?
Yes, if we make every text editor the same, then that's for sure.
If everything becomes Emacs, all the Vim users are going to be sad.
Yeah, I'm not using it anymore then. But I don't believe that there's a need to do that for text editors because honestly, for textual editing, I believe that LSP is standardized enough. The only thing that it's really missing is the syntactic highlighting, but that's coming soon. Well, they're saying soon from a long time now, but that's definitely coming at some point. So for the text editor, honestly, it's standardized enough. And yeah, I believe that the only services that we would find hard to standardize right now would be small enough and possibly new enough so that users don't already have old habits to use them.
Okay. So one of the mantras we had back when we worked on Monto was that the IDE should be really stupid. They shouldn't even try to reason about code at all, because whenever basically there's an abstraction barrier right between the view and the model, which is code. What do you think about this? How are your contributions relating to that?
So I believe that manipulating model and not just code is the best thing that we can do. And the way I see it, in this approach that I propose, first of all, we should be able to have a bit like Monto actually, but a service that takes as an input a model and manages the translation and the parsing and the translation. But on top of that, we could also have a language server protocol that, a language server of the LSP server. It's a bit hard with the terms sometimes. We could have an LSP server on top of the parser that would just be fed the text and manage all of the text editing stuff. And also in the case of Monto specifically, I don't see any reason why we couldn't just have support for all of the services offered by Monto right now.
Sorry, what was that question for me?
No, I'm just thinking out loud. But did I answer the question? I forgot completely about that.
Well, I asked about the abstraction barrier between the view, which is the IDE, I guess the editor, and the model, which is the code. But I can also ask another way. So it's something else I wanted to talk about is, and that we struggled with and we couldn't find an answer for, is where should the code actually live? Is the code with the user, or is the code with the service, or somewhere in between? Or I don't know.
So basically, where do the workspace should be? Is that the question?
Yeah.
That's a very good question.
Or I mean, we don't have to find an answer, but what are the pros and cons of putting it here or there?
Well, the pros of putting it on the cloud is obviously the fact that then you can just have a completely persistent environment that you can reach from everywhere and anywhere. If you don't have internet access, then you cannot do anything. That's the con. And if you have it locally, obviously you can work as long as you have access to your computer, but you could at some point lose everything if you have a hard drive failing or things like that.
But what are the consequences for the language services? Like, I mean, the code needs to go to the language service, or the language service needs to have access to the code.
So in this particular
Like also
case,
maybe in terms of performance, or, you know,
yeah,
number of messages.
So
like that.
here that would definitely depend on two things, at least. Where the language services are, because they could also be very close to the workspace, even though the workspace is on the cloud. So in this case, it wouldn't impact performances a lot. And also, what do the language services need? What I mean by that is that, so in the case of Coulon et al., one of the things that was the most expensive in terms of performances was the serialization and deserialization of the data. But if we could have a way to only send the necessary data to the service and not just serialize and deserialize the model all the time, no matter where the service is, the impact wouldn't be that much.
I mean, so one scenario that we ran into was we had projects with multiple files, and then you want to do something really simple like cyclic inheritance checking.
Okay.
But it requires all the source files. So you need to have, I mean, you need to scan the entire workspace.
Okay.
And so if the language service and the code are at different places,
you need to send the whole repository.
Right. Or you need to mirror it and sync it, or, you know, it's like, whatever you did, it seemed to remain nasty somehow.
So on the deployment aspect, such a service would obviously be better as close as the workspace as possible. But what was the output of this service? Basically, what was it showing to?
Like an error message for cyclic inheritance, like if classes inherited from each other, usually recursively.
So, okay. I haven't thought about that, but right now I'm just considering if there would be a need for some specific services that are so reliant on the workspace that they should just be integrated directly inside it. So I'm just thinking out loud about that. I don't have an answer right now. But yeah.
Yeah, I think we probably, I mean, one approach might be to start distinguishing services that can be implemented compositionally or modularly, where they look at one unit at a time, like simple syntax highlighting and things like that. But you know, like name resolution, to name another non-local service. Or I mean, sometimes you might be actually able to implement it, you know, modularly, but I mean that opens another can of worms.
And sometimes you might be able to implement it, and it will work on just a small project, but will not scale at all, I guess. So that's also something that needs to be taken into account if we want to have a proper performance a proper performance study. Okay.
Maybe I can ask one final question, which is about something different.
Obviously. Go ahead.
So in the very beginning of your presentation, you explained that there's all these IDEs and I understood what you said is that there's not enough sharing between the implementations of IDE services for different languages. But now I'm thinking about all these IntelliJ plugins. I mean, at least they're all sharing IntelliJ. I mean,
yes.
I think isn't PyCharm, WebStorm, aren't those all just plugins of IntelliJ really? I'm not sure. So I'm wondering, is the state of the art as bad as we make it to be, or is it actually kind of manageable?
I think that IntelliJ is really an outsider in this. They actually have a model where they manage to have a proper standardization of the UI and a way to reuse their services inside their own environments. But they are, as far as I know, very closed source oriented. So these services can be shared between the different platforms of IntelliJ, but of course not for other IDEs.
But if they could do it, then others can do it as well. So is this a solved problem, or?
Well, they could do it, but only for but still a limited set of languages. I don't think, for example, that there is right now an IDE dedicated to Golang, for example, from the IntelliJ side. Or I don't know about Rust, actually. There might be one. But still, they put a lot of effort in order to do that, but they still don't support all of the existing languages. So it's I believe that it's still an issue that hasn't been fixed yet.
Great, thank you very much.
Thank you, Sebastian. So I now give the floor to your two supervisors. I don't know who would like to start. Benoit?
I can start. Because I was not the main supervisor, so I will let them know. Okay, really, I would like to thank first, of course, all the jury to join today. It was really a pleasure to have this discussion and to see all this discussion with Pierre. I would like also to thank also Benoit for inviting me to work on this PhD. And okay, it's really something which is close between software language engineering, software architecture. So I really enjoy the discussion and all the things we do together. Of course, I would like to thank Pierre to join in Rennes, going for the Sous conference and joining here. So it was really a pleasure to have you in the team for 3 years and being there and having some idea regarding technical stuff, discussing with people. So it's really a pleasure. And so I would like to congratulate you to be there today, because we know that it's always a lot of work to defend the PhD. So thanks a lot. I think I took plenty of notes regarding the discussion. So I think we will put a meeting probably Monday to discuss some of the points, but it's part of the game. But really, thank you. And I hope that you enjoy this trip and with us. And really, thank you.
Thank you, Olivier. So now over to Benoit. Benoit, over to you.
Thank you very much, François. Thank you very much, Pierre, for this presentation. And I would like to really thank you for this adventure that we had together. We started more than 2 years ago in Toulouse when you was in your master internship, and then you moved to Rennes for doing your PhD thesis. I should acknowledge that I learned a lot from you and the work that you have done. not only on the research side, but also on the technological side. I should admit that I discovered a lot on how the new generation is actually creating software and developing software, how the operating systems can be as exotic as the ones that you have on your laptop. So I discovered a lot of things from both research and technological things that was really exciting. So thank you very much for this. I mean, we are doing this job for collaborating with PhD students and for learning from them, and I should really thank you for this. You have been really persistent and proactive all along these 3 years. You have been very proactive on the idea and pushing your own view on this. This thesis is really yours, and I think you can be very proud of this. So I really thank you, and I took a lot of pleasure working with you. I would like also to thank the jury members. Thank you very, very much for all the work that you did, for the reviewers that did the reviews and the report on the manuscript, and for today's all the members with a very, very great discussions that you had with Pierre. I was really eager to jump so many times in the discussion. I mean, I'm really looking forward to meet with you very soon for discussing so many interesting points with many things that I would like to discuss with you on this. So I cannot take all of them right now, but of course your question, Emma, about code reviews and in more general how we can combine the IDE with the forges, because code reviews are mostly happen in forges, whatever you're using GitHub or GitLab, and we have the IDE on the other side, and I think we are all sharing this feeling that it's unifying more and more, and at some point we'll have just a big environment where, according to the different activities that we want to do, it will be reconfigured and providing the right interface with the right services, such as we can smoothly do the exact activities that we want, but always in the same kind of environment, probably in the browser, by the way. So I think there's many things very interesting on this. Sebastian, thank you, by the way, because we was really leveraging on everything that you did in the past. So Monto was really the key initiator of the research path that we had during the Pierre thesis. So thank you very much for all the great work that you did, and that was really inspiring for us for doing this. And I'm just jumping into your comment about the standardization, and I think one of the things that we are sharing with maybe Pierre is the fact that maybe we don't need this standardization, in the sense that instead of having standardized protocol, maybe we can have a unique way of describing this protocol and making all the tools reconfigurable according to a description which is given of these protocols, which means that we don't need to standardize the protocol themselves. But then comes the problem of the front end, exactly what you said. So to avoid this problem, because we was aware of this, and we didn't want to jump into all these problems that the front end can raise, right now we focused on the execution tools. And by focusing on the execution tools, that was mostly on the back end, with a few of things on the front end, such as, for example, the control panel of the debugger, which is pretty uniform. Whatever the IDE that you're using, the control panel is also almost the same thing. A couple of buttons for going forward and backward and running and pausing your execution. So that's why a way for us to avoid this big challenge to manage with services that have a very big rendering in the UI and in the front end. That's a very big challenge and probably a big perspective for us. And so I'm mostly jumping on comments from people online, because I have the opportunity to discuss with Mark on site afterwards. So Richard, thank you also very much for all your comments. Especially, I do think that at some point we can automate, and the IDE could be a self-adaptive system that, according to the environment, it could generate automatically the best configuration according to both the environment and the task that the user want to do. And for this, of course, we need to collect a lot of information from the specification of the languages, but also from the usage in the past. So we need to collect a lot of data, which are pretty easy to collect, by the way. I mean, collecting data from the IDEs is probably not the worst case for us. So that's an opportunity that we need to leverage. So many things to do on that part. And again, very nice perspective to look at. So I'm just finishing here because I could continue so many for so many long times. So now I'm just looking forward to meeting with you very soon in a physical setting, I mean. So thank you again, and looking forward to see you soon.
Thank you, Benoit. So as the chair of the PhD panel, I'm the last one to ask questions, but I only ask one question. So first, I would like to thank you for both your manuscript and your talk, as our members have already mentioned. So I learned a lot. I knew a little bit already about this through previous collaboration with Benoit and Fabien, but still there were many things I didn't know. So my question is more a methodological question. I understand this is a difficult point. So it's not at all a criticism about your work. It's more because I'd be interested to hear about your ideas on this. So you started your work by a motivation regarding the fact that there was many IDEs and many DSLs, and understood that the goal was basically to try to obtain more modularity and reuse, and to be able to basically configure environments that are optimized for the task or the workflow or the processes and so on. And I was wondering if you had 3 more years and you wanted to start to quantify the benefits that your contributions have, might provide. How do you go to do this? And of course, you could do big user studies and in a big company, but let's assume you don't have the budget or the time to do that. If you wanted to start quantifying, what could be your options?
I believe that the first goal that I would have, if I had just 3 years, would be to have a complete demonstrator in which basically I can take existing language workbenches. So, for example, Xtext or JMOC, but it also uses Xtext, but basically any language workbench, and actually derive from this workbench all the tools that we have now. So in the case of the JMOC Studio, for example, that means a way to execute a program having omniscient debugging and trace support, and be able to go back and see this trace. To have all of these tools generated in a way that I can actually just integrate them in multiple IDEs. The major ones being, well, Eclipse is already done, but definitely VS Code, Eclipse TEA, and of course in an environment directly inside the browser. So that would be the 3 targets for all of the tools that could derive from a language workbench. And if I have this demonstrator, then I can start looking for more money to to support the rest of the studies, I think.
Okay, thank you. That's a valid answer. So we'll, in the interest of time, we'll end the session of questions now, and we'll move on to the deliberation of the panel. So I don't know if we're staying here or moving to another room. Okay, so I'll ask the audience to leave the room, please.
And we should stop the YouTube.
Yes.
caméra est ici ou là-bas? La caméra, elle est où? C'est celle-là?
La caméra, elle est sur le public, là.
Elle est sur le public.
C'est celle qui est là-bas. C'est celle qui est derrière le public. Vers le...
Là, oui. Ah oui, parce qu'elle est plus large là. En fait, c'est peut-être ici qu'il faut aller.
Mais après, je peux...
Non, c'est très bien.
Très bien.
Merci.
Je reste là?
Non, non, c'est bien.
So, Pierre, the jury has deliberated, so I'll give you a quick summary of what we've written in our report and then what our decision was with respect to your PhD. So, in your PhD, you presented your work on the development of integrated development environments with a particular focus on DSLs, and this is a topic that is both complex and very important nowadays for the industry. You've presented 3 contributions from your thesis that are based on a number of international publications. Your talk was precise and well argued, as judged by the jury. The jury particularly appreciated your extensive use of illustrations and the pedagogical progression of your presentation. You then answered many questions from the jury on many aspects of your work. This demonstrated your expertise in the field and your ability to reflect on your work, which is quite promising. Also, we would like to emphasize the fact that in the course of your PhD, you've performed some substantial development work, because sometimes with the effort that goes into this kind of work can be underestimated, and that you've shared the results of this development effort with the scientific community through an open source code repository, in particular within the GMOC project. So for all these reasons, the jury is unanimous in recommending that you be awarded the degree of Doctor of the University of Rennes, with our congratulations.
So can you hear me? Okay. So there are a lot of people that I need to thank. So first of all, from my jury, I want to really thank both of my reviewers that made some very great points on the manuscript, and I haven't addressed them all yet, but you can be assured that I will not publish the manuscript before having addressed all of the remarks that were very pertinent. I want to thank, of course, the rest of my jury for the very interesting questions, and I hope that in the future we will be able to continue the discussions that we had. So I don't know how this will be organized, but I guess that my 2 supervisors will be able to manage that. So that will work, definitely, and we'll be glad to have these discussions. I want to thank my 2 supervisors also that had to really drive me for these 3 years and a half now. The ending was a bit rough, and for that I'm sorry, but thank you for still giving me your time, even if you didn't have that much time to give. And I want to thank the president of the jury for giving me my title, and also to manage all of this, of course. I want to manage the guy in the box over there that manages all of the technical stuff for this defense. So that was a lot things to not think about during this presentation. And I want to thank, of course, all the rest of the diverse team that was always there with their great and precise insight, and also the joy And yeah, I want to thank my family for being here, supported me for all of this time too, and managed to still cope with me, even even in the difficult times. I don't know if there are many people watching the live, but if there are, I want to thank them too. Thank you for still taking some of your time to see this presentation and all of the interesting talks, even if you weren't able to be here. And I think I have. I think I'm done. Did I forget anything? Raise your hand. No. Okay. Oh. Okay. So thank you to the 20 people connected on the YouTube. And with this, so last two things. If you want to, that's not obligatory, we could take a quick picture in front of the screen with all of the jury members. So if someone could take pictures, because actually I don't have anything for that.
Sebastian, could you just switch on your camera for the final picture?
Gwendal, can you put back the? Can you have the slides and all of the jury members on top of this, or is it not possible?
I think you don't share your screen.
Yeah, I'm doing it.
No, but we remove it.
Je peux avoir tous les membres du jury parce que là, ok, il y a tout le monde là, ok. Ouais. Okay. Thank you for all the pictures. And so second thing, very sorry for the people who are in remote, but there is a pot right now, so that drinks, a cocktail if you want. It will be in the room 100, so we'll go there right after.
Okay, so congratulations again, Pierre, and thank you again very much, Richard, Emma, and Sébastien for attending. I'm very, very sorry. We'll definitely miss you during the drink and the cocktail, as we missed you for the lunch, but just next time, for sure. So thank you very much for connecting, and have a good day for you, Richard, and a good evening and weekend for Emma and Sébastien. And looking forward to seeing you soon.
Thank you.
Likewise.
Thank you.
Thank you so much.
Bye-bye.
Thank you.
Bye-bye.
Au revoir.
Congratulations, Pierre.
Yeah, and congratulations.
Congratulations, yes.
Thank you again.
Bye-bye.
Bye.
Hey?